Welcome to all. I am Professor Sandeep Aher. I have completed ME Design as a lecturer Sandeep Polytechnics, Sandeep Foundation, Nasik. So friends, today we are discuss about the new subject that is Advanced Manufacturing Process. It shortly says AMP and that course code as 22563. As 22 indicates, as per the MSBT curriculum, every 5 years that course is revised. So G scheme that is the 70, and then after 5 years that is the 22, then 5 indicate for the 5th semester and 63 as the course number. Course means that is the subject. So after completion of diploma or after learning this subject, student can able to know the certain course outcome uh, as per the subject. First, CO1 maintain non-conventional machining process to produce the complex hard machine components. And second, produce components using milling machine. CO3 choose relevant machining process to produce gears. CO4 maintain CNC machine to produce components effectively. CO5 prepare CNC part program for simple components. Then CO6 maintain the functioning of automated components. These 6 COs after completion of this course, so students should hands-on practice on the throughout life. So that purpose these course outcomes are there. So first, clear that advanced manufacturing process. Let me first explain what is the exact manufacturing process. So manufacturing process that already studied in the lower semester, but in manufacturing process the raw material is converted into finished product. It's a simple definition. Now advanced means existing manufacturing process, some modified version as per the industry 4.0, that is the advanced manufacturing process. Then I will show the teaching and examination scheme for this course. Course I mean this subject advanced manufacturing process. So that is ME5I means mechanical engineering 5th semester I scheme. There is a one table is given. So teaching scheme, examination scheme, then theory and practical distributions are there. So in teaching scheme, learning, tutorial and practicals. So learning hours are the 4 hours. There is no tutorial. Then practical for the 4 hours in the weekly. Then total credit as a total 8 hours in this week. Now theory. So after learning this course, so when MSBT has organized this final exam for 3 hours paper, that paper should be distributed 100 marks in terms of ESE and PA. So ESE means end semester exam. So that end semester exam you conduct 70 marks, and out of these 70, so students should at least 28 marks are compulsory for the passing. Then PA progressive assessment, that is totally distributed for the 30 marks, and that 30 marks indicates star. That means in contain these two class tests plus one micro project. So one class test for the 20 marks. So two class tests that average out of 20 plus 10 for the micro project, that total 30 marks. And then as your mark sheet 70 plus 30 total out of 100 marks. So student should require at least 40 marks. Then practical, again for the same subject, because that subject is the core subject of the mechanical engineering. So that is again similar pattern and same exam and progressive assessment. So and same exam here 50 hatch as the symbol indicate the external assessment for this practical. Then progressive assessment, again in the throughout semester students have complete as per the scheme, a number of practicals are. Then prepare this file. You will get out of 50 marks. Then this total addition again 100 marks means as observe the subject total for the 200 marks. Then for this course a certain syllabus. So the total 6 chapters are there. Then teaching hours. Then total marks also distributed as per the MSBT norm. So first chapter non-conventional machining methods. Then second, milling machine and milling processes. Third, gear manufacturing. Then fourth, fundamental of computer aided manufacturing. Then CNC part programming. Then six, automation and robotics. So as per the sixth chapter, so teaching hours are distributed like this. The total hours are required 64, and then total marks will be distributed as per the chapter 1 to chapter 6, that total 70 marks. And for this subject, learning sources for the student can search again your reference books. So I am showing here certain books, title of book, author and publication. Just go through this and search again more information for this subject. Then I'm again showing to software or learning websites. For this site, you may go through this, you will get more in number of videos, you will get more understanding. That purpose that sites are given here. Then I will start this subject for this unit number 1, non-conventional machining methods. So as per the every chapter, every content, so certain course outcomes are there. Likewise, in this chapter, the course outcome is to maintain non-conventional machining processes to produce complex and hard machine components. Means as per the manufacturing method, students should know what are the advanced manufacturing process for the today's age technology. That purpose the chapter is included because the chapter is very important for this subject. Now here the chapter contain and its subtopics. We have covered fundamentals of non-conventional methods, what is the need of that conventional methods and non-conventional methods, then working principles, setup, constructions, installation setup, process parameters, then advantage, disadvantage and application. Likewise these processes are given here: electrode discharge machining processes, wire electrode discharge machining processes, then electrochemical machining processes, plasma arc machining processes, abrasive jet machining processes, ultrasonic machining processes, electron beam machining processes and laser beam machining processes. Now students, in this lecture we have covered these all processes one by one. So let's start the first chapter, that is of or in between first topic, that is fundamental of non-conventional methods. So let me first explain the first manufacturing process. Raw material is converted into finished product. So that's why advanced manufacturing means, I would like to say, in last decades, so for manufacturing purpose the technology is not available, so stone is used for the manufacturing purpose. Then after that conventional methods are there, like lathe machine, drilling machine, milling machine. Then after second war, that technology not fulfilled for that situation. So that purpose we have find again new research material like carbide, tungsten, ceramics. So that machining not done this manufacturing. So that purpose, advanced manufacturing processes are used for this today's age technology. Now, why that need of that manufacturing processes? So situation where traditional machining processes are unsatisfactory or uneconomical means simply that non-conventional methods take over the limitations of conventional manufacturing processes. So why that need of these processes? First, workpiece material is too hard, strong or tough. Now in conventional machining processes, workpiece and cutting tool is the direct contact and cutting tool is always harder than the workpiece. Then and then this manufacturing process is done. But in non-conventional, that workpiece is hard and cutting tool is soft material. Then workpiece is too flexible to resist cutting forces or too difficult to clamp. Now in this process there is no contact between cutting tool and workpiece. In conventional is the direct contact of the cutting tool and workpiece. Next, part shape is very complex with internal or external profiles or small holes. In conventional manufacturing process, it is not possible to manufacture exact complex or counter or internal or small holes. So these are the limitations for the conventional. So take over these limitation and this non-conventional process can done the every manufacturing. Then requirement of surface finish and tolerance are very high. As per the industry 4.0, that requirement is too much different. So conventional methods are not feasible to get that parameters. So that purpose these non-conventional methods are used. So that surface finish and tolerance are very close. So now temperature rise or residual stresses are undesirable and unacceptable because in conventional manufacturing process cutting tool is direct contact with the workpiece, so should strike some forces and to generate the heat. For that purpose, that strength gets vary. So that's why here, without physical contact, that manufacturing is done. So next, that is the importance of non-traditional machining. For that question may be asked for the 2 marks. What are the importance of non-traditional machining process? Means simply says the advantages of these processes. So first, complex shape can be machined. Means any type of complex shape can be machined by non-traditional machining process. Then second, machining in inaccessible areas. So conventional that human being can directly operate these workpiece cutting tool parameters. But now here machining is inaccessible areas means that machines operate automatically. Then third, low tolerance as non-conventional methods can get the better surface finish and close tolerance. We get more precise manufacturing. So better surface integrity means no surface defect line. Then high surface finish because in today's manufacturing as in nano measurement directly. So that's why surface finishing is very good. Then miniaturization of products Means small delicate parts are manufacturing by these non-conventional methods like landline phone and computers and laptops, etc. Then, as per the non-conventional methods, material removal rate is also high. Then, I would like to show you it is a classification of non-traditional machining processes. I already said that in traditional machining processes, workpiece and cutting tool is the direct contact, and here non-traditional machining processes there is no contact between cutting tool and workpiece. So first, that non-traditional machining processes are classified into three types. You may divide again four types, but I am here third and fourth type combined. So first, according to these, which energies are used here, like mechanical energy, then thermal energy, then electrochemical energy or chemical energy. Likewise, mechanical energies means that energy is used in ultrasonic machining. USM stands for ultrasonic machining. Then WJM means water jet machining. Then third one is abrasive jet machining process. So here only mechanical energy is used, not heat is generated. So that's why mechanical base. Now second segregation is thermal based energy. Means whenever this process is going on, so heat is generated. So that's why this under this thermal process. Now first, EDM, electro discharge machining processes. Then second, WEDM means wire cut electro discharge machining processes. Then laser beam machining processes. Then electron beam machining processes. Then plasma arc machining processes. So these are under these thermal processes. Then electrochemical or chemical under these three processes. So chemical machining, then electrochemical grinding machining processes, then electrochemical machining processes. So these are the non-conventional processes. So let us see one by one. But before this, just compare the difference between conventional and non-conventional methods. So that points can use again as some advantages and disadvantages for the conventional and non-conventional methods. So first, I would like to say that conventional means like lathe machine, drill machine, milling machine, wherever is the direct contact of cutting tool and workpiece. Now, in non-conventional, there is no physical contact of cutting tool and workpiece. So first, direct contact of tool and workpiece. In conventional, or consider to the lathe machine, the direct contact of cutting tool and workpiece. And non-conventional. Tools are non-conventional technique like laser beam, electrical arc, or erosion or chemical action. So these methods can use to cut the material. Then third, cutting tool is harder than workpiece. Already said that in conventional, cutting tool is always harder than the workpiece. But in non-conventional, there is no contact of the cutting tool and workpiece. So tool material is it is soft. Then third, tool life is less due to high wear because there is the direct contact of the cutting tool and workpiece. It raises the number of forces. So that's why tool life is less. Now here non-conventional tool life is more because there is no contact. So tool wear rate is near about zero. Then fourth, generally macroscopic chips formation because in every process material can be cut. So that's why that cutting material will in form of microscopic. Macro means there is a form of raw material like chips, burrs. So chips like material should be different. These are the different types of chips formation. Continuous chips, discontinuous chips, and discontinuous with built up edge. So that's why these are the macroscopic chips formation. Now in non-conventional material removal in form of melting, vaporization or erosion. So that's why this is a burr free or chip free material removal because there is no contact between cutting tool and workpiece. Next, material removal takes place due to application of cutting force because in conventional machine cutting force is acts directly on the workpiece so that material removal by means of the cutting force. Now here it uses different energy like thermal energy, mechanical energy, electrochemical energy for to removing the raw material. Then it's conventional, suitable for all material means like wood, metal or any type of materials can be done by this conventional manufacturing. And it cannot be used to make a prototype pass effectively because there is the contact between cutting tool and workpiece and it is a human operated. So should not get the perfect dimension by this manufacturing. Now here non-conventional not suitable for the all materials means as per the which energies are used here thermal, chemical or electrical as per the materials are different it can be used to produce prototype parts very effectively means because you get the closed dimension parts.